This video is about a robotic arm being integrated with a TOC analyzer and isotope ratio mass spectrometer. This is the software showing the measurement of the sample by the isotope ratio mass spectrometer. So there are two peaks, very small ones. It's the end of the first sample. So in some time, the second sample will start. So now the Aurora, the TOC analyzer is finalizing its measurement, its operations. The robot's there waiting, and the software here will be stopped at any moment. Sorry, it's the first time I'm doing this, so I'm not sure about the timing. So then I'll explain something what I'm doing here. So you see, the computer has no one operating it. It's all controlled by scripting. AutoWI. AutoWI is a scripting language, and it enables the control of software, different software in synchrony, and this can be very useful to control different instruments also in synchrony. So as I showed, that there are three different devices that are being controlled here. The stable isotope mass spectrometer, we call it IRMS. So from now on I'll call it IRMS. The TOC analyzer and the robotic arm. The robotic arm is a out sampler. The robotic arm was very cheap. It was $89. So now it finished the measurement. This is automatic. So I told the script finish the measurement, and then it will finish, and then it will start the robot now. So the robot goes to the second vial there. Moved inside the second vial. Then it starts the sample number 2, the IRMS software, and then the Aurora software, the TOC analyzer software also starts. It gives some messages, and the script will answer to them as if it was a user, and then it will start. So now let's see. So it's doing its thing. So there is a pump, syringe pump here. It's sucking some water. It's the rinsing water. It's inside this bottle here, this big bottle. And then it does it as a cleaning process, so it cleans the lines. It takes some water again. Cleaning the lines and everything. So now it's waiting for a mouse click. This mouse click will be given automatically by the script. So it already did. So now the Aurora will move again. This time it's priming the sample, so it's taking some water from the vial there. does it to clean the line as well, the sampling line, and also the reactant chamber, that is this glass tube here. Actually, it didn't go there. Surprise. I can modify this setting. I can tell it to do it. So it's priming the sample. Anyway, it's not a big thing. It's just, this is just to demonstrate that the machines can work together. There are many configurations that can be modified. Now it will suck the sample. It will take 2 milliliters from the sample, and then it takes 1 milliliter of acid that is in another bottle there, and it will pump that inside the reaction chamber here. See, I don't know if it's possible to see, but there are some bubbles coming out. This is the carrier gas, the helium. Soon, because of the reaction that takes place here, so there is some acid added to the sample, and and the sample has inorganic carbon, so the inorganic carbon will become CO2, and we'll see a peak here in some time in the other software there, the IRMS software. I can, like, the script now is in a sleep mode or waiting mode, so sometime it will do something else. It's okay if I change the focus here to this window. So there are two reference peaks here. This is the way the isotope measurements work, so I won't explain everything. Those are not the sample peaks. This is what matters now. The sample peak will come soon. Sorry, this is a long video, but these analyses take time. So yeah, please wait a little bit. It won't take very long, and we're going to see a peak. As I explained in other videos of this series, everything is controlled by the script. So AutoIT controls all softwares together, so they work one after the other in synchrony, and then we can couple the equipment. So yeah, the peaks are coming. See? So this is the first peak, because there will be two peaks. This is the inorganic carbon that comes from that reaction with acid. It's a big peak because it's a very concentrated solution. I'm afraid it can be too big and go above the scale of the IRMS. But this is just a preliminary test, and really the first trial of the approach here, like using the robotic arm as an outsampler. I already demonstrated in other videos that it can be precise, like for reaching the vials. It can reproduce its movement. Now I'm showing that it can be used together with the other machines. That is the ultimate purpose. Next step will be to refine this. So as I mentioned at the beginning, I was surprised that the machine didn't reach the chamber. So okay, the robotic arm is moving again. So it goes back to the original position. As I explained in the other video, it needs to do it every time. It goes back to the original position so that it can reach other positions after that. If it doesn't do that, it's impossible to program the movements. So now it's going to the rinsing station. Rinsing station is this bottle here. Stays here for a few seconds just to dilute the water outside the needle. It's probably not the best cleaning technique. I'm still thinking about refining this. Ideally some running water would be used, probably, followed by a rinse in a bottle like that. Yeah, I'll think about that. It's a noisy robotic arm, but it does its job. It's doing very well. Yeah, it's noisy. So yeah, it did the second sample. You didn't see it doing the first sample, but okay, it's finished for now, the robotic arm. I can put back there to the IRMS screen. So you see the peak. It's a big peak. It's working. It's very good. I'll just leave it going for a while so you can see the next peak. It will take some time, okay? It will be some more 7 minutes or so. In this meantime, I can talk about the process here again. So what happens? There is the robotic arm that you saw working a few seconds ago. It's my out sampler, so I bought this for $89. It's a toy. I made some modifications on it. It was designed to be used with batteries, but I adapted a power supply using those wires here just below. You probably cannot see very well, you see, go inside the box. So I drilled those holes and put the wire on the positions that the batteries would go. Then I also removed the claw, so I can show you here the claw of the robotic arm that I got out. The claw was quite weak. This is the claw. Yeah, so I don't use it because it's not necessary for this purpose here. So I removed this claw. I also glued this stainless steel line here, more or less a straight line. There is a connection here between the line, the stainless steel, and 1/8 inch Teflon tube that goes to the IRMS. So now to the TOC analyzer. Now it's injecting the persulfate. The persulfate is a chemical that will react with the organic carbon here and will produce CO2 from oxidation. So you see that the peak for the inorganic carbon is already gone. So in some time the peak for the organic carbon will come. Yeah, so the robot has a USB control that goes here on the wall. Here in the lab we have this wall USB connector, so it will go to that computer. So that computer here on the other side of the room will control the robot and also the other equipment here. So everything's controlled by this computer. This TOC analyzer here is the Aurora TOC analyzer. It's made by OWI Analytical US. It's a US company. It comes with this out sampler. This out sampler here costs about $20,000 Australian dollars. That was the price that people paid here, while the robot here costs $90. And so far it seems that I can use the robot instead of this. Also there is the IRMS here. So some time ago it was developed a method by some guys in Canada that allow the coupling of the TOC analyzer with the IRMS. There is this interface here in the middle that does some chemical reaction, but it's not controlled by the computer. There is just a furnace there at 700 degrees that helps some chemical reactions to happen. So basically what I want to demonstrate here is that it's possible to use the TOC analyzer together with the robotic arm and save a lot of money. So the like $20,000 about someone can save. This TOC analyzer is it's relatively common. It's probably not the most common. Shimadzu is common. I made another video showing that the robot can be used with the Shimadzu TOC analyzer. And so my point here is also that I can use the robotic arm with any kind of device. Here I adapted it for liquid sampling in these TOC analyzers. The Shimadzu also do total nitrogen. So TOC is total organic carbon. So here it's being adapted to measure organic, inorganic carbon and inorganic carbon. Not only the concentrations but also the isotope, because it's also coupled to the stable isotope mass spectrometer. So, and everything here is being controlled by a script. So you see the second peak already coming, the organic carbon peak coming. The script here is written in AutoIT. If you see the code here, it's a short code. If you have practiced programming, you know this is a very short code. Of course, this is not the only code that I use. There are some functions here that I define. These functions are in other files, so I made a kind of a small library. Still, it's a simple way of programming. I don't need to know anything about communication protocols and things like that. Everything is like high level in the sense that it's easy for a person to do it. And here you see the peak went over the scale of the IRMS, changed the subject, so it's blowing up the limit there because it's too concentrated, but it's nice because it still demonstrates that I'm getting the complete reaction here. So going back to the software thing, so using AutoIT I can control all the softwares and they work together in the way I defined. So it's a very powerful tool and very useful. In the past I also used AutoIT to couple two equipment. I will show you guys because this is only a peak. Be back soon here. Let's see the lab. This is where I work. Best job in the world. Many machines to play. So this is the other Aurora that we have. Yeah, we are rich, but it's more or less broken. I mean, it almost doesn't work, but it has an outsampler. So the first time I used the scripting was to make this outsampler here work together with the Vinta. Vinta is the most precise machine, possibly the most precise machine to measure inorganic carbon in water now. It's made by Ludger Mintrop Marianda in Germany. The only thing I did, I took the sampling needle and coupled here to the needle, sampling line, coupled here to the needle of the Aurora outsampler, and I can make them work together. I didn't make a movie of that, maybe I'll do. And this way we can achieve very precise measurements of inorganic carbon concentration and also using our outsampler, so we don't need to be here all the time, because originally this was designed such a way that we need to be here all the time. This is the Shimadzu TOC analyzer that the other day I demonstrated that I could use the robotic arm here as well. This is the outsampler that comes with it. I don't know the price, but I guess it's at least very least $10,000. Let's go back there. So the peak is almost finished. It's a long analysis, as you see, so it takes more than 18 minutes. It's long. But it worked, so I'm very glad, because I really wanted to demonstrate that. There are some things that need to be improved, but it's a matter of working on them. And I'm sure that it's possible to use cheap robotic arms as substitutes for these expensive auto samplers that people normally use. Nowadays, things are getting much more accessible, so there is the scripting that allows us to improve the softwares and use them in concert and in synchrony. There is Arduino, that is that microcontroller that allows us to build anything. So imagine you can build something. Arduino has a computer control. You integrate that using OWI with any other machine that already have a computer control. I didn't want to start with Arduino, although I plan to someday do something using Arduino, because it's much easier to start with the robotic arm. So the robotic arm was cheap. I spent about 1 month doing what I'm doing, like playing and trying to make things work. With Arduino, I would need some more time because I know nothing about electronics. So now the Aurora is finishing again. I don't know if we got this at the beginning. It's already more than 20 minutes of movie here. It's getting becoming a huge file here. Yeah, it's finishing. So the peak is finished there as well. It was a huge peak. I think I can stop now. Oh, we can wait until it goes to the next sample. No, let's not wait because it's too much. We already saw at the beginning that it goes from here to the next sample. Thank you for watching, and yeah, if you want to learn more, talk to me.